Hello, chemists. Let's talk some SI metric unit prefixes. Now, these prefixes actually provide a range of units for a single base unit. A base unit might be a meter or second or gram, for instance. So in this table, what I have listed is the prefix name, the symbol, and then the scaling factor of that prefix. And notice that these are all based on factors of 10. That's one of the nice things about the metric system. And then I also have listed an example for that particular prefix, and then a comparable example, another way of writing that example. Now, I'm going to focus in on one right here. Take a look at the kilo prefix. So in this particular case, I could say for this example, 1 kilogram is equal to 10 to the third grams. So 10 to the third is 10 times 10 times 10, or 1,000. So where does this 10 to the third comes from? Well, it comes from the scaling factor right here. So this factor tells me how many of the base unit do I have let's say in this case, how many grams do I have in 1 kilogram. So in other words, there are 10 to the third grams, or 1,000 grams, in 1 kilogram. That's what this factor is telling me. For instance, if you let's just go up one step to mega. Well, there's the factor is 10 to the 6. 1 megasecond is equal to 10 to the 6 seconds, or 10 to the 6 of the base unit, my base unit is seconds, is equal to 1 megasecond. All right, so these factors here are really telling me how many of the base unit are in that particular prefix. Now, notice here, this particular example used grams, this particular example used seconds. Those units are totally interchangeable. So in other words, I could say 1 kilosecond is equal to 10 to the third seconds, or 1 kilometer is equal to 10 to the third meters. So just because this example is using grams doesn't mean I can't switch it out with another type of unit. Now, in this last in this last column, I have a comparable example, another way of writing the previous example. So if I take this previous example and if I divide both sides by 10 to the third, I'll actually get 10 to the minus 3 kilograms is equal to 1 gram, or 0.001 kilograms. That's what 10 to the minus 3 is. 0.001 kilograms is equal to 1 gram. Now, both of these convey the same information a little bit differently, but those of you here that have watched my my units video recognize that these are actually conversion factors, and we're going to be using these conversion factors in just a little bit to convert between different prefixes and different units. In terms of chemistry, I would say kilo, mega, giga, tera. These are probably your most popular prefixes that we might use. Since we work on very small scales, if we're talking atoms or molecules, we're not talking about very big masses. We're not talking about large length scales. So these aren't quite used as much, although in terms of masses, a kilogram is a very popular measure in chemistry, although not always do we work with that much material. This table, this is the second half of the table. Now this is where the factors here, notice all the exponents are negative. So all of these factors here, again, based on factors of 10, are all less than 1. So we have our prefix name, our symbol. Notice the symbols here are all lowercase. On the previous table, some of those were uppercase. And then our example and our comparable example. So let's take a look at the milli prefix as an example. So 1 millisecond, I'm using second as my base unit here, is equal to 10 to the minus 3 seconds. That 10 to the minus 3 comes from the factor. So this is telling me, that factor tells me how many of the base units, 10 to the minus 3 seconds, which is 0.001 seconds, is in 1 millisecond. Comparable example over here, if you divide both sides by 10 to the minus 3, right? You'll get 10 to the third milliseconds, or 1,000 milliseconds is equal to 1 second. So both of these are conveying the same information. They can both be used as essentially the same conversion factor, and we'll see that in just a second as well. Maybe as another example here with centi, 1 centimeter is equal to 10 to the minus 2 meters, and 10 to the minus 2 is 0.01. So 0.01 meters is equal to 1 centimeter. Or a lot of people like to think of it in terms of, if you think of a metric stick with gradations for centimeters, there's 100 centimeters in 1 meter. Again, in terms of chemistry, I would say centi, milli, micro, nano, pico. Sometimes femto are used quite a bit in terms of describing either mass or length scales. Femto, atto can also be used. Femto certainly in terms of describing very short time scales. Atto could very well be used to describe the energy scales that we might see for atomic or molecular energies. So let's take some examples on how we might use these prefixes and their conversion factors. So for an example, I just clipped this row right here directly from our table on the preceding slide. And again, we have this relationship that 1 kilogram is 10 to the third grams, or 10 to the minus 3 kilograms is equal to 1 gram. Now, these conversion factors, I can really think of these as ratios between different units. So in other words, I could write 1 kilogram to 10 to the third grams. That's what I've got here, 1 kilogram to 10 to the third grams. That's equivalent to 10 to the minus 3 kilograms to 1 gram. That's what I've got written here, 10 to the minus 3 kilograms to 1 gram. Now, if you're wondering how can those be equivalent, well, take a look at what's going on in the denominator here. 10 to the third is 10 times 10 times 10, which is 1,000. Right? 10 to the minus 3 is 1 over 10 multiplied by itself 3 times. 10 to the minus 1 is 1 over 10, and that's 1 over 1,000. So this number over here is equivalent to 1 divided by 1,000. This number right here is equivalent to 1 divided by 1,000. So these are equivalent. Now, when I wrote these, I put kilograms in the numerator and grams in the denominator. So you can see my grams are in the denominator. If I want, I could have put the grams in the numerator. There's no reason why I couldn't have done that, but I have to be consistent. So I could say that there would be 10 to the third grams per 1 kilogram. That's what I've got written here, 10 to the third grams per 1 kilogram, or 1 gram to 10 to the minus 3 kilograms, 1 gram to 10 to the minus 3 kilograms. And we're going to need that flexibility to be able to put either grams per kilograms or kilograms per gram when we're doing our unit conversions. So we have to have that flexibility to be able to write it either way. And I'll give you some examples in just a second. So let's say we wanted to convert 62.6 grams to kilograms. Well, before we do that, I do want to point something out here. Let's go back to some earlier math from our lives. If we're multiplying fractions, I can factor that 25 as 5 times 5. Now there is a rule that, right, if I've got a number in the numerator, it will divide out or cancel that same number in the denominator. So I could have a 5 in the numerator and that 5 in the denominator cancel. That's going to leave me with 3 times 5 divided by 2, or 15 halves. The point I'm making here is you can do the exact same thing with units. So if you have, for instance, grams up here and grams down here, those grams will cancel if I got grams in the numerator and grams in the denominator. All right, so as a reminder, I have to refer back to my table to know my conversion factors here. I'm going to go ahead and rewrite the same conversion factors that we just had in the previous table, on the previous slide. And I'm going to take the 62.6 grams and multiply that by 1 kilogram to 10 to the third grams. Now, if you're wondering why am I using this conversion factor and not this conversion factor, notice I want grams to be in the denominator since I already have grams in the numerator. This 62.6 grams is equivalent to 62.6 grams divided by 1 if I wanted to think of this as a fraction. So grams are in the numerator. I want grams in the denominator. And it doesn't matter which one of these two I use. I use this one. I could have used this one. Matter of fact, I think I do that in another example here in just a second. So the way that I've multiplied this conversion factor times my value, grams will cancel. The only units left over are kilograms. And there's my final answer with units of kilograms. That's exactly what the problem was asking me to give. Now, if you haven't watched my video on significant figures and my other video on significant figures and calculations, I recommend you go back and take a look at that, because when I have to use my rules for significant figures, this number here has an infinite number of significant figures. This number here only has 3. So my final answer can only have these 3 significant figures. These preceding zeros are not significant. Well, here's the other example. So I could have used this conversion factor. Again, I've got grams in the denominator. So grams are in the denominator. Grams are in the numerator here. They'll cancel. The problem asked me to give the answer in kilograms, and I'll get the exact same answer as the previous example. All right, so either of these conversion factors could be used, this one or this one. I tend to use this one simply because I tend to think of how many grams might be in a kilogram, or the fact that that factor had been 10 to the third or 1,000. All right, well, here's something. Let's convert there's a lot of zeros there, 0.000734, I almost said angstroms, amps to microamps. You might not be familiar with the unit of amp. Amp is a measure of current. It's really a measure of how much charge is flowing per unit time through a circuit. In terms of us making that conversion to microamps, all I'm doing is just changing the prefix. So really, I don't even have to know what the unit of amp represents. I just have to make sure I make the correct change, or the correct prefix change, and use the correct factor. So again, I'm going to go to that table. I'm going to pull the row that involved micro, and here are my relations, right? Now, the way that this is set up, it's set up in terms of liters. Well, like I said, these base units here of liters are interchangeable, so I can insert amps, capital A, for both of these. So my prefix is 10 to the minus 6. That tells me I have 10 to the minus 6 amps per 1 microamp, for instance. So if I do that, I can write those conversion factors right over here. So this term here, this 1 microamp to 10 to the minus 6 amps, comes directly from 1 microamp is equal to 10 to the minus 6 amps. And this term here, this half of the equation, 10 to the 6 microamps per 1 amp. And that's exactly what I've got written here. Now, this one down here, I've just taken the reciprocal. So I put amps in the numerator, and I got microamps in the denominator. So if I'm going to convert from amps to microamps, the conversion factor that I want to use better have amps in the denominator so that they cancel. The units of amps cancel. So I'm going to use this first conversion factor. And again, it doesn't matter which one I use, I'll get the same answer. So here's my 0.00734 amps. I'm multiplying by, in this case, 1 microamp to 10 to the minus 6 amps. Amps will cancel. There's my units left over, 734 microamps. So again, this conversion factor has an infinite number of significant figures. This one here, these preceding zeros are not significant, so there's only 3 significant figures here. Using the rules of multiplication and division, I can only have 3 significant figures in my final answer. And the units here, happily, are microamps. Again, I could have used this half of the conversion factor, so 10 to the 6 microamps per 1 amps. Amps are in the denominator to cancel the amps in the numerator. And I get the exact same answer. So I could have used either one of these. If I had chosen to use this one here, one of these down here, then I would have had amps times amps, and they would not have canceled. So I would not want to use this one. I would want to use this one if I had been given been given the problem in microamps, and the problem were asking me to convert to amps. In that case, I want the microamps to cancel. One last example here. Now, in this case, what we're doing is we're jumping from one prefix to another. My suggestion in this case is to take the 2.21 kilometers, convert that to meters, and then go from meters back to micrometers, right? Yeah, conversion factors do exist to go from kilometers to micrometers, but unless I think about it, unless I really want to put some brain power into it, I don't really know it offhand, although I could use those factors to figure it out. So I'm going to take 2.21 kilometers, and I'm going to go back to our table here, and I know that, again, I can replace grams with meter. There's 1 kilometer to 10 to the third meters. So the way that I'm going to write this is I want 10 to the third meters in the numerator and 1 kilometer in the denominator. So kilometers will cancel. So I can write 10 to the third meters per 1 kilometer. And kilometers will cancel. And right now I'm just left with units of meters. So I have to still convert that to micrometers. And I'm going to pull the row from the table for micrometers. And again, replace liters with meters. And matter of fact, this is the one I tend to like to use, but either one would work fine. 10 to the 6 micrometers is equal to 1 meter. And I'm going to want meters in the denominator. So I'm going to write this as 10 to the 6 micrometers per 1 meter. And that's exactly what I've got here. Now, if you wanted to use this one here and said that there's 1 micrometer per 10 to the minus 6 meters, in other words, you'd have 10 to the minus 6 down here, and a 1 in the numerator here for 1 micrometer. Yep, that will work fine. You'll get the exact same answer. Meters will cancel. There's my final number. A whole bunch of zeros. It becomes much more convenient to write it in scientific notation. I do have a video on scientific notation. If you haven't seen that, you might want to check it out. All I have to do is move that decimal place to the left, in this case 9 times. There's 6, 7, 8, 9, and I got my answer in scientific notation. I only have 3 sig figs, right? 3 significant figures, because this has an infinite number of significant figures. This is an infinite number of significant figures. This number only has 3 significant figures. So my final answer only has 3. Well, I could have done it the other way, like I was just saying. So instead of using this conversion factor, I went ahead and used this one, so that there's 1 meter per 10 to the minus 3 kilometers. Kilometers will cancel. And then I guess I use this one here, 1 micrometer per 10 to the minus 6 meters. So replace liters with meters. And again, I want meters in the denominator, so that they'll cancel, and I'll get the exact same answer. So I hope you found this video useful. Thanks for watching.